Hey everyone, how is it going? So in this video, I'm going to talk about a custom attribution modeling approach. So if you're using GA4 data, for instance, a lot of people say that GA4 data is the problem, but I think the real problem is attribution models. So you might be working with first touch or last touch. These are the usual sort of attribution models that are there within most of the platforms as well as analytics tools. And then there's also the newer black box, which is called the data driven one. The problem is that it's exactly what I just said. It's a black box. You don't really know what's going on under the hood. So a better idea is to actually have a custom attribution model. This can have a logic of your own, or it can actually have a mathematical approach to it. So the example that I'm going to show you here is going to be a mathematical one, and it's going to use methods like, say, Markov chains. This particular example will specifically focus on Markov chains, but it can the approach that I'm taking has the potential to use Shapley values or other kinds of custom mathematical data driven models. So this, by the way, is an extension of the series that I've already started. So this is part of the GA4 BigQuery attribution model series, and I've already shown you, a previous version of the code where you have actually prepared the data. So the data preparation is an important part of the process, and the final output of that is this. This is the final output of that, where you have the you have sort of aggregated the different customer journeys by their path. So this is very much like you would see in GA4. So you're basically re-aggregating that data. So once you take it into BigQuery, of course it doesn't come in this format, right? So that's an aggregated report, a conversion path report, or whatever that's called. I forget the name, but so essentially, yeah, this is a conversion path report, and this is what you have to reconstruct from scratch once the data is within BigQuery. So you have these different columns like total conversions and total conversion value. Once you have created this from scratch, then you can start using some attribution modeling approach to it. So there are two major approaches. One is the heuristic models approach, and the other is more data driven approaches. So by heuristic modeling is meant really the first touch, last touch, these ones, like linear or even time decay, because these are based on simple rules. They're not using any mathematical understanding of the data set that you are working on. So instead, it's a predefined rule. So you're saying that, okay, it's linear means that it's going to be the same in each touch point, the weightage, or the credit is going to be distributed depending on how close it is to the final point in the conversion, or to the last touch. So that's time decay. So in this way, you can have different kinds of weightages depending on the rules that you set. Again, if it's first touch, then it gets 100%. If it's last touch, it gets 100% if it's the last one. So these are all heuristic models. Now the question comes, how we can approach with Markov model. So this is a mathematical model. Again, in the previous video, that was the in the first video of the series, I actually explained the data preparation. The second one, I actually explained the mathematics of Markov models. But just to give a brief recap of that, Markov chain is basically an approach that depends on the concept that the current state only depends on the previous state, not any other states. And by state here is meant different touch points in the customer journey. So basically it means that if the person has seen your ad on Google Ads, for instance, and that state is basically dependent only on the previous state, where he or she might have come across another ad in a different channel, maybe, right? So maybe Facebook ads. So that is the only dependence that is there. This is the assumption of the model. Based on that, you extrapolate and you iterate and you create the entire loop. So once that loop is created, you get something, when you have something like this, you are able to again reconstruct it from scratch and build a model on it. So based on that concept, you have two calculations that you have to do within Markov chains method. One is called the transition probability, which is the probability of transitioning from one state to another. Remember, again, state is the different channels in the customer journey. And the second one is the removal effect. So the ultimate calculation of contribution of each of the different channels or the different states in this journey is by removing one of them. So it's kind of like a holdout and seeing the overall impact okay, on the probability of conversion on the entire channel, the entire aggregate conversion probability. So basically how much, so that removal effect is going to give you how much is the attribution, the credited attribution based on the Markov model. So this is the underlying concept. So first, you install the required package, and then you go, and if you look at the directory here, as you can see, so this has been custom attribution package. That's the short form in cap. That's the acronym, and then you are applying the Markov model, and you can see there are different methods available within the package and functions. So the next is to actually load the data, and you can see, as you can see, it's attribution df, that's the data frame. And from there, this kind of just like I showed here, this is the final output of the data that has been loaded into the system here again, while running the custom attribution model. So again, do definitely refer to my previous two videos. First, with the first one will be for the data preparation, the second one for a detailed understand explanation of the mathematics of Markov chains. Then you have to use a certain token, and then you have a Markov result value data frame, where you are trying to create, where you're adding different things here. So basically trying to understand, you're basically applying the Markov model uh, function here, or the method, or rather the function, and this has got several parameters. So it's taking in all these values here: the path, the total conversion value, total nulls, meaning that there are no conversions, the paths, and then also the total number of conversions. So this is all, these different columns are being taken as the parameters for this particular Markov model function. And then you have the final attributed value based on this attribution model. So it's, you can see what it does in the backend. When I execute it, it's building its attribution transition matrix, the number of paths elaborated, there are simulations. So that's what this does, right? I mean, it carries out multiple simulations, and based on that, ultimately it reaches a convergence level. So these are the attributed this is the attributed value data frame. And you can see now there are some new things here. So you have different channels. So instead of the paths, now it has broken it down to individual channels. That's the whole idea of it, right? And you also have the channel position. So in that path, in that specific path, so you have the path ID. This particular channel was in position 2, for instance. In this one, it was position 1. And then you have the total number of conversions and conversion value associated with each channel as a touch point in each of the journeys. So that's the data frame that you get from this one as an output. As you can see, quite a few data points there. And then there's another one. So we're going to also have a heuristic models. So heuristic models is what you already get. This is something that you can recalculate. You can sort of do this entire thing here within using Python code, using the data set that you've generated from GA4 within BigQuery. And the heuristic models is again a inbuilt function in this package, and you can see that several parameters have been passed on, again from that same data set that we earlier used, and this is the output that we get from it. Similar kind of output, except that for this one we get first touch conversions, last touch conversions, and linear touch conversions, because we are looking at multiple attribution models within the same within the same sort of output. So this is the advantage, like you didn't actually have to calculate these, right? I mean, otherwise there's a lot more mathematical stuff going on, because you obviously have to calculate each of these. But since we are using a ready-made package, this is basically giving you an output very quickly. And this is Markov result transition. So Markov model has been used here again, and you can see this time we are trying to calculate the transition matrices. So this is what is giving us the transition matrices. Like for this path, from transitioning to one from one channel to another. So this is the from, and this is the to. So this is, what is the probability? This one is the probability of going from this particular channel. So the start is right, that's the start of the very customer journey, from channel 1 to going to channel 2, for instance. This is the transition probability. So this is again for each of the this is basically for all the for the entire customer journey. Okay, all the transition probabilities have been listed here. So that's also useful. And then you start doing something called the aggregation. So this is important, because we already saw that we had the data for the different paths, for the different channels, but you see that the channels are sort of repeating, right? And that's not very useful, because that's not what we want. We don't want it by individual paths. That's not our objective. We want to understand, or get an understanding of the aggregate picture of the channels, um, attribution, or how much credit can be attributed on an aggregate level. So these are the three pieces of code that are actually trying to do that. The first one here is, again, is basically summing up the conversions for each channel. That's what it's doing. As you can see, it's grouping all the channels, based, and basically it's applying a, it's like a pivot table where it's getting all the conversions based on the three different heuristic models. Then you are creating an aggregate, again another aggregate, this time by channel as well as by total conversions, and resetting the index here. Then you are renaming a couple of columns, and then basically you have another output, which is called the merged one, which is merging together by the different channels. So these are the few steps together, and then you are filling up all the missing values with 0. So this is basically what is giving you the ultimate structure, and then you have to reshape it, because you're trying to get the channels, the models, and the conversion. So that is the output that you want to have from this. So basically from here you will have the channels, the models, and the conversion. So for each channel, instead of having duplicates across many rows. So that aggregation process has been carried out through these pieces of code. And if I were to visualize it using the Seaborn package, this time what I'm going to do is going to do a complete attribution channel analysis, and I'm going to do that across all the attribution models actually. So this is the last step of this process till now. There are actually other things that you can do with the package that I'm talking about, but this is also very pretty useful. As you can see, it's a pretty neat output from on the data set that I was working on. As you can see, it's pretty close, the number of conversions for each of the different channels for all the attribution models. But in this case, for instance, there's quite a bit of difference in this one. For others, for organic search, there's difference. Not too much difference between between the different models for the channels in this case. But again, this will differ. Like in many cases, you'll see that meta has got completely been overlooked. Okay, it might be part of the attribution journey, right, or the customer journey. So how is it actually getting, and how is it getting any kind of recognition or credit? So you might be interested in actually getting a better idea, right? Because if it is very click oriented, if the attribution model is very click oriented, then a channel which is closer to the natural progression of the customer's journey, to the end of the natural progression of the customer's journey, is probably going to get more benefit. And we all know that that's Google usually, because that's closer to the end of the journey. But something that's higher up in the funnel, sometimes it's going to be involved, but it's not going to be closer to the end of the journey. So in those cases, we might want a balance, apart from a much more balanced view than just first touch, last touch, or even linear. And data driven is a black box, so that's why we need the custom model. So in this example, I've only shown you the Markov conversions, the Markov model, but there are other approaches that can be used as well, right? So those approaches can be, like I said, Shapley value is there, and there are some other methods here in this package. So if you're interested in executing this, if you're interested in trying this out, or if you are really curious about knowing what really moves the needle, then I think you should give this a go. Just let me know. I'll just share my contact information in the description. You can reach me out over LinkedIn as well, and then we can discuss how we can actually get started with this. Okay, because yeah, attribution is a tricky business now. And yeah, I know that it should start with right tracking first of all. So that's a very important thing. Your conversion tracking should be properly in place. um, you might go with server side tracking. There are many advanced approaches to do that, but the next step is attribution modeling, which conversion tracking alone can't do. So you need a sophisticated system, or at least a system that works. Does not necessarily have to be complex. This is not very complex, what you just saw, but you need at least a robust technique that will give you the right output. So yeah, if you want to get closer to the ground truth, just let me know, and we can have a discussion on how we can proceed. So that's it for this video. Hope this was useful. If you have any questions, like always, please leave it in the comments or just get in touch with me. Thanks for watching. I'll see you in the next one.